For this video, we're going to be looking at lesson 3.3, intersection and union of two sets, focusing on examples. So our first example, we have the athletics department at a large high school offers 16 different sports. We got badminton, basketball, cross country, running, football, curling, golf, hockey, lacrosse, rugby, cross country skiing, soccer, softball, tennis, ultimate frisbee, volleyball, and wrestling. So we're going to complete the Venn diagram below using the sets. So we have sports that use balls, and then sports that use an implement such as stick, club, or racket. So I'm going to take what I have up here, and I'm going to write it down in my Venn diagram, and then from there, that will allow me to answer the questions to the side. So the numbers in the universal set, the numbers in the B set, and the numbers in the L set. Actually, no, that's I for implement. So like for the first one, we have badminton. So badminton just uses a racket. So it would go in I here. Okay, the next one we have is basketball, which would just use a ball. So it goes in the B set. Next one is cross-country running. So cross-country running uses neither, and so that one's going to go on the outside. And then, so we've done that one, we've done that one, we've done that one. Football just uses a ball, so football goes in the B set. Curling uses a broom. So curling is going to go into I. Golf uses both because it uses a golf ball and a golf club. So it's going to go in the middle. Then we have hockey. So hockey uses a puck and a stick, so it goes under I. Lacrosse uses both because it's got its stick that catches the ball, so lacrosse. We got rugby, which uses a ball. So it goes into B. We got cross-country skiing. I'm going to put that into I for implement, just based because it's got its skiing poles. And then I missed an I. Good enough. Okay. Then we got cross country skiing. Then I'm going to do soccer. So soccer just uses a ball. What do we got left here? Softball, which uses a bat and a baseball. So softball goes in the middle. We got tennis, which is used as a racket and a tennis ball. So that goes in the middle. We got ultimate frisbee, which uses neither. So that goes on the outside. We got volleyball, which uses the ball, so that goes under B. And then the last one is wrestling, which uses neither. Okay, so my number in my universal set, so that I can just go from the problem. I said 16 different sports, so that's how many sports I have, so 16. The number in my ball set, so that's including everything that's out here that just uses a ball, as well as everything in the middle that uses both. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 9 for B. And then the number in I, so that including everything that just uses the implement as well as everything in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8. Sorry, I included cross-country skiing twice. It's just once, so 8 there. So moving to the next page to answer these questions. So using the formulas to determine the number of sports that require the following types of equipment. So we have a ball and an implement, such as a stick, club, or racket. So that is the number in the intersection of B and I. So that's in the middle. So in the middle, we had 1, 2, 3, 4. So it's 4 there. So we want only a ball. So my notation for that one, I'm going to use N for number. And then for only a ball, so what I want is this piece of my circle. So it's got 1, 2, 3, 4, 5 all together. And the notation I use for that is I'm going to say B because I'm focusing on ball, but I only want ball, so it's going to be minus what's in I. So it's B minus I, and so that leaves me with the 5 that are just using a ball. And then it's either a ball or an implement. So this is the principle of inclusion and exclusion. So if I take everything in B and everything in I, that means I've accidentally done the overlap twice. So I take everything in B, everything in I, and I minus the overlap once, and that tells me how much I have. So what that is I have 9 for B, I have 8 for I, and then there was this 4 for the overlap. So 9 plus 8 minus 4 works out to be 13. So I got 13 sports all together that I'm dealing with. So I can go back here just to double check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I've done my math right there. Then last part of this question is neither a ball nor an implement. So this is what's outside. So math-wise, so for my complement, it's the stuff that's outside my circles. I'm going to take my universal set minus how much I get inside the circles, and what's left over is the outliers, the stuff that doesn't fall into the circles. So my universal set was 16. I'm going to minus how much I got from my circles, so the union of the two, which is 13. So there's 3 sports that don't fall into the circles, and I can go back to my Venn diagram just to double check. So there was wrestling, ultimate frisbee, and cross country, so the 3, so matches the math that I just used. Okay, so we got example 2 now. So we have Jim surveys 34 people at his gym. He learned that 16 people do weight training 3 times a week, 21 people do cardio training 3 times a week, and 6 people train fewer than 3 times a week. So the number of people that use the gym, the universal set, has 34 people. The W, so the number of people that do weight training, was 16. And just a reminder that 16 is for the full circle, so including the overlap, but I don't know what the overlap is just yet. And cardio was 21 for the full circle. So I'm going to answer these questions, but I'm going to just do my math down at the bottom to fill in my circle first, and I missed a number because I did not deal with the 6 people. So 6 people train fewer, so those are the outliers. They don't fall into the circle. So I'm going to do the numbers that should be in the circle. So I'm going to take the 34 that's in the gym, the 34 people that are using the gym, minus the 6 people that are doing it fewer than 3 times a week. So there's 28 people that either do wrestling or cardio. Now I'm going to figure out my total. And just a reminder, when you do the total, you get the extra overlap there when you add the 2 together, because you've accidentally added the overlap twice. So if I do the 16 plus the 21, I get 37 altogether. So to find the middle, I'm going to take my total minus how many people that are over there, and what's left over will actually give me the overlap. So there's 9. So then to figure out how many people just do the weight training, I'm going to take the 16 that do it minus the 9 that's in the middle, and so I get 7 people that are just weight training. And then for the cardio, I have 21 people that do cardio, 9 people that are doing both, so that leaves me with 12 people that are doing just cardio. So just to fill in, so I got 7 that are just doing weight training, 9 that are doing both, and 12 that are doing just cardio. So 7 plus 9 is 16. 16 plus 12 is 30. 16 plus 12 is 28, which is the amount of people that fall into the circle. Okay, so for this, the number that are in W, so that are doing weight training, so that was 16 altogether. The number that are in cardio was 21, and the number that go to the gym was 34. The number that is in the union of W and C, so if I take W, which was 16, plus C, which was 21, minus my overlap, using the principle of inclusion and exclusion, I get 28 people altogether. Actually, I won't write it there. So I got 28 there. And then for the intersection of W and C, the ones that are doing both. So in the middle there was 9 people that are doing both. And so for the complement of W union C, I'm going to take the amount of people that, actually, no, sorry. I'm going to take the number of the people that go to the gym minus the people that fall into the circles, which was the 28. And what I end up getting is 6. So there's the 6 people that don't train 3 times a day, or 3 times a week. So in summary, the principle of inclusion and exclusion, to calculate add the number of elements in A and B, then minus the common elements. If 2 sets are disjoint, they contain no common elements.